A forgotten Commodore 64 has made its way to my workbench. It's dirty, neglected, and seems to be in need of help. Today we're bringing it back to life. Let's see what stories it holds, and whether we can restore this classic machine to its former glory. This Commodore came to me through a listing from a second-hand store. The ad, it simply said, "Black screen. No photos, no further details. Just that." So now it's time for the first real test. Let's power it on and see what happens. Nothing. No signs of life whatsoever. No startup screen, no flicker, not even a blink from the power LED. It's completely unresponsive. In a case like this, the very first thing to check is the power supply. If the system isn't booting, we need to make sure it's actually getting the voltage it needs. I've covered how to test a Commodore 64 power supply in a previous video. Feel free to check that out if you want to follow along. In my case, the power supply is working just fine. So next step, let's take a closer look at the fuse and the components that handle the incoming power. Something down the line might be shortcutting. The first thing I noticed, the fuse was blown. Now, a blown fuse is never just a random occurrence. It usually points to something else going wrong somewhere on the board. Possibly a short circuit, a damaged trace, or a failed component pulling too much current. In rare cases, it could just be age, corrosion, or thermal fatigue over decades. But that's the exception, not the rule. So it's time to take a closer look at the board. I'll be scanning for anything unusual. Burnt components, suspicious discoloration, or bad solder joints before replacing the fuse to avoid blowing another one. At first glance, the board looks fine. No obvious damage. So the next step is to focus on the components themselves. On this board revision, both the VIC and SID chips are socketed, which makes things a bit easier. Any of them are candidates to be the cause of the problem. To be safe, I'm going to pull both chips from their sockets, not only to test them separately later, but also to prevent any further damage in case they're still functional. Next, we're going to check the key components responsible for handling power on the board. First up, the diode bridge, a set of 4 diodes responsible for rectifying the incoming AC voltage and converting it to DC. I'll include a diagram of the bridge rectifier on screen so you can follow along with the testing. Using the multimeter in diode mode, place the positive probe on the anode and the negative on the cathode. A healthy diode should show a forward voltage drop, typically between 0.5 and 0.7 volts. Once the bridge are checked and confirmed to be in good shape, it's time to move on to the voltage regulators, specifically the 5V and 12V lines. If you'd like to see a more in-depth explanation of how to test these voltage regulators, I've covered that in one of my previous videos. Feel free to check it out if you're following this repair step by step. With all the preliminary checks out of the way, it's time to install a fresh fuse and see what happens. I'll be powering on the system cautiously, keeping a close eye and nose out for any signs of trouble. Looks good. No smoke, no burnt smell. I'll check the fuse again. Still intact, that's a very good sign. After a few checks, I notice there's no power reaching the system. Let's test continuity at the power switch. No continuity. We'll need to take a closer look at it. Let's take it apart, clean it, and check each piece. The switch uses 2 metal contacts that close the circuit when in the on position. They might be misaligned, or maybe dirt is blocking the connection. Once cleaned and reassembled, the switch is working properly again. Back to the Commodore's board, we've got voltage in the circuit. Time to run a few checks. We'll verify the voltage regulators, the 5 volts lines to the RAM, and before reinstalling the video and sound chips, we'll make sure the 12 volts rail is okay. With the chips back in place, it's time to check if our Commodore has finally come back to life. We've got video. The VIC chip is working, but the sound is missing. Unfortunately, the SID chip didn't survive, and we'll need to replace it. The SID is a valuable chip. It's no longer manufactured in its original form. There are some interesting modern alternatives, though, and we might explore those in future videos. Make me know in the comments if you'd like to see some reviews. Back to our Commodore. Let's see if we get sound with the replacement SID. We have sound. Our Commodore is back to life, and it's a joy to hear it sing again. It's time to clean up our dirty Commodore and bring back that original shine. Since this one's pretty grimy, I'll start with a cleaner that contains a small amount of detergent. Before using any cleaning product, it's best to test it on an inner, hidden part of the case, just to make sure it won't damage or fade the original color. After that, I'll use a bit of isopropyl alcohol and a soft cloth to avoid scratching the plastic. Isopropyl alcohol can also help remove marker stains or any leftover sticker or label residue on the case. Avoid using products like acetone or other harsh chemicals. They can damage the plastic or leave visible marks on the case. Finally, all that's left is to remove the keycaps for a deep clean. The keyboard works fine, but it definitely needs a thorough key-by-key cleaning. Our Commodore is looking fantastic, and it's ready to bring us joy for many years to come. Cheers, my friend. Thanks for watching. If you enjoyed this restoration, give it a thumbs up and consider subscribing for more retro tech repairs. Got questions or ideas for future videos? Drop them in the comments. See you in the next video.